Okay, we're going to be adding and subtracting fractions. So there's really only one rule that you need to know to be able to add or subtract a fraction, and that is same denominator. Denominator is a fancy math term for the bottom number. For example, if you have 1/5 plus 3/5, then your denominators are both 5. You can add those together. Remember, when you're adding and subtracting, the denominators do not change. So if that's a 5 and that's a 5, then that's going to be a 5. You only add the top numbers. So your answer would be 4/5. After you finish adding, make sure this is in simplest form. So let's do one that wouldn't be in simplest form. Let's say we had this problem. Bring down our 10. 3 plus 1 is 4. This would be an unfinished answer. They're never going to have this as an answer on the test. They're never going to have an unsimplified fraction as an answer, because that would give you 2 correct answers. So what you've got to do is you've got to divide both of these numbers by their greatest common factor. Now you can actually divide by any common factor as long as you keep going until it's in the smallest form possible. But the easiest thing to do is divide by the greatest common factor. Now this only has 2 common factors, 1 and 2. Never divide by 1, that doesn't get you anywhere. So 2 is really the only factor that will get you anything. So if you divide the top by 2 and divide the bottom by 2, 4 divided by 2 is 2, 10 divided by 2 is 5. You end up with a simplified fraction. Let's say we have this problem. 3 plus 2 is 5. Bring down the 15. You should know your times tables. You know that 5 goes in both of these numbers. If you divide both of those numbers by 5, you end up with 1 and 3. So 1/3. Now those are pretty easy. So we're going to move right along to when you don't have the same denominator. Now the common mistake that people make when they don't know how to add fractions is they'll add the top numbers and they'll get 2, and they'll add the bottom numbers and they'll get 5. And they'll say 2/5. You can't do that. You cannot add or subtract when the denominator is a different number. So you have to know your times tables again. You have to know a number that 3 and 2 will both multiply into that's the same. Now, if you want to do it the easiest route, you find the least common multiple. But any common multiple will actually work. So let's say I didn't know that 3 times 2 was 6. Well, I could still use 12. I could use 18. Any larger multiple will still work. You're just creating more work for yourself in the end because you have to simplify it more. So I know that 3 and 2 will both go into 6. Now, most of the time, you can just multiply these numbers together to get this number. But sometimes that makes the problem very difficult because these numbers get very big, and you're much better off to find the least common denominator than you are to multiply these numbers together. So your second step is you've got to turn this denominator into this denominator. Well, you do that by multiplying. So 3 times 2 is 6. So you have to multiply the 1 times 2 and get 2. This is called an equivalent fraction. You create an equivalent fraction by multiplying it top and bottom, or dividing it top and bottom, like we did up here. This is actually an equivalent fraction of this, but we're going the opposite direction. We're dividing. Down here, we're multiplying. So 1/3 is equivalent to 2/6. So down here, you have to multiply by a different number to get 6. 2 times 3 is 6, so you multiply that one times 3. These numbers will always be the same, and these numbers will always be the same, but this number will never be the same as this number. So 1 times 3 is 3. Once you get to this point, add your top numbers together, bring your denominator down, check to make sure it's in simplest form. The only thing that will go into 5 and 6 is 1, so that means you're done. Now, part of the time, you're not going to want to multiply these. These are pretty small numbers. If you multiply them, you could still solve this problem. It wouldn't be that much work at the end to simplify it. But once these numbers get bigger, then it's going to make the problem very difficult. So I'm not going to use 20, even though you can use 20. You always check to see if the smaller denominator will go into the bigger denominator. And you should know that 2 goes into 10 5 times. So if the smaller denominator will go into the larger denominator, you can use the larger denominator as the least common multiple or least common denominator. So since this is already 10, there's no changing up here. You multiply it times 1, so there's no reason to write that down. This number has to change. 2 times 5 is equal to 10. So 1 times 5 is 5. So you should know that 5/10 is the same as 1/2. So those are equivalent fractions. Now you add your top numbers together, bring down your denominator, check to make sure it's simplest form. You should be able to tell by looking at these that it's not in simplest form. If you know your times tables, you know that 2 will go into both of these numbers. 2 and 1 are the only 2 common denominators again. So if we divide by 2, we'll get 3 and 5. So your final answer is 3/5. Now, what I was saying earlier is it's not always a good idea to multiply things together. Let's say you had 3/25 plus 4/5. And you tried to do it the easy way, or what you thought was the easy way, by multiplying 5 times 25 and getting 125. There's no reason to do that, because if you check, your smaller denominator will go into your larger denominator. So you can use 25 as your least common multiple. So since this is already 25, you just bring over the 3. This one you'd multiply times 5 to get 25. You always start with the denominator and then move up to the numerator, which would be 20. 3 plus 20 is 23. Bring down your 25. Now, sometimes this will do you some good. It doesn't always work perfectly, but I know that 23 is prime. The only thing that will go into 23 is 1 times 23. And since 23 won't go evenly into 25, then I know that I'm finished. Now, if this was a larger number like 46, well, 23 times 2 would be 46. So sometimes it will work in your favor, sometimes it won't. You just kind of have to take each problem one at a time. So this is a perfect example of the smaller denominator will not go into the larger denominator evenly. You don't necessarily want to multiply these, because then you're going to end up with 96 on the bottom. There's a much easier route you can take if you know your times tables. And I've said it multiple videos. I say it in my class all the time. The most important thing that you can learn before taking this test is your times tables. Memorizing your times tables. Not counting on your fingers, not counting dots on a sheet of paper. Memorize your times tables from 1 to 10. If you want to do a little bit extra, 11 and 12 will help you for this example right here. So if you know your times tables, you know that 2 times 12 is 24. and 3 times 8 is 24. So the least common denominator for these two denominators is 24. Now, if you don't realize that, you use something like 48, that will still work. 72 will work, and then of course 96 will work. But 24 is the easiest route. So down here you have to multiply 12 times 2. So 5 times 2 is 10. 8 gets multiplied by 3 to make 24. So that's multiplied by 3 to make 9. 9 plus 10 is 19 over 24, and you're finished. If you would have used 96, you would have had, let's see, times 12 would have been 60 times, nope, I'm doing it wrong. Times 8 would have been 40. Times 12 would have been 36. And you would have had 76 over 96. And then you would have had to simplify that and find common denominators and all kinds of stuff. I think I did that right. I did it in my head. Until eventually you get down to that right there. Okay. So don't do it like this. Learn your times tables. Do it like this. Moving on to mixed numbers. No, we're not going to move on to mixed numbers. We're going to do one improper. So what will 3 and 5 go into? This is a case where you just multiply them together, get 15. Times 5 times 5, you get 10. Times 3 times 3, you get 12. 12 plus 10 is 22. 15. This is what's called an improper fraction. You can't turn this in as an answer unless you're in functions and you're doing slope. Slope is the only reason to have an improper fraction on the tape test or the GED test. Every other question you have to simplify this. So you take the top number, put it in the bracket, take the bottom number and put it outside the bracket. You're going to divide. 15 goes into 22 once. Write your 15 down, subtract. 22 minus 15 is 7. You take your remainder and you put it back on top of the new fraction. So this 1 is your whole number, 7 is your new numerator, and you go back to your original denominator. Then you always double check to make sure this is simplified. So 7 and 15 don't have any common factors except for 1, so you're finished. So your final answer is 1 and 7/15. You can't turn it in like that. So first thing you do is work with your fractions. You ignore your whole numbers until the end, and you'll see why here in a minute. So you could use 24. It wouldn't hurt you. But you should always check, will 4 go into 8? Yes, it will. So you can use 8. So that's already 8, so you move the 5 over. That needs to get multiplied times 2, so that needs to get multiplied times 2, which gives you 6. Now, add your 6 and your 5, get 11, bring down your 8. You have an improper fraction. So you have to put the 11 inside, 8 outside. 8 goes into 11 once. And I see a lot of people do this backwards. They put the 11 on the outside and the 8 on the inside. So if you instantly would get a decimal, you know you got these flip-flopped. You should automatically get at least a 1. Now once we start multiplying and dividing, you'll get a bigger than 1. But usually adding and subtracting, it's always going to be a 1. Put your 8 down here, subtract it, take your remainder, which is 3, put it back on top, put your 8 denominator back on the bottom. Now don't stop here, because this is just the fraction. Since we have a mixed number, two mixed numbers, you've got to add these in also. So you would add 1 to your 5 and to your 6. So that all together is 12. 1 plus 5 is 6, plus another 6 is 12. Bring your fraction over, 3/8. It's a lot of work. It's a lot of places to go wrong, and it takes a lot of time on your test. So if you haven't practiced these thoroughly, your best bet on these questions is to guess and move on. These take a lot of time. If you don't want to put in the effort to learning all this, then don't waste your time doing all this, because you're probably going to go wrong somewhere. And I know that sounds like terrible advice, but the best advice I can give you is, if you don't know how to do a question, guess and move on, especially on the GED. The GED, you don't really have time to solve every problem. If you have time to solve every problem on the GED, then you're probably someone who already has a college degree, or maybe even already has a high school diploma. If you struggle with math, your best bet on a test is to do the problems you know how to do the best, and then with your time left, go back and recheck the ones you skipped. And if you don't know how to do them still, guess and move on. Don't waste your time on these if you don't know how to do it. And I say that for this next problem, because this confuses a lot of people. So if you're already having trouble with these, I would suggest turning off the video, because this is going to confuse you more. So this is subtracting with mixed numbers and having to borrow. Now, if you don't have to borrow, it's just a subtraction problem. Now, just like with adding, first step is finding a common denominator. The smallest one that 8 and 5 will go into is 40. I just multiplied 8 times 5 to get that. So this gets multiplied by 8. 3 times 8 is 24. This one gets multiplied by 5. It's 5. So remember, we're not adding. Don't get confused and start adding 5 and 24. You have to subtract. Well, you can't take 24 away from 5. So this is where it gets really confusing. You have to borrow. You have to go all the way over to your whole number, and you borrow 1 from your whole number. Turns into a 9. That's also the reason why you leave the whole numbers for last. So what you do is you're adding 1 to this fraction. Don't just put a 1 in front of the 5. That is the absolute wrong thing to do. I've seen people do it all the time. That is not how you borrow, because even if you put a 1 here, then you'd have 15 minus 24, and that's still not big enough. What you're doing is you're adding an equivalent fraction to this fraction. So since you have to have a denominator that's 40 to add, then your new fraction has to have 40. Now, anytime you're borrowing 1, this has to be equal to 1. And to make this equal to 1, you have to put 40 on the top. Whatever your denominator is, that's what you're putting top and bottom, because 40 divided by 40 is 1. That's why we're doing that. The reason why we pick 40 is because your denominator is 40. So add 40 and 5, you get 45. The 40 stays on the bottom. Now you can subtract 45 minus 24. So if you need to, you can do all this off to the side. If you're used to doing it like this, that's fine, because you're going to be doing these without a calculator most of the time. 5 minus 4 is 1. 4 minus 2 is 2. So your new numerator is 21. Your denominator is still 40. Now, if you know your times tables, you'll know 3 times 7 is 21. 1 times 21 is 21. None of those numbers go into 40 except for 1, so we're simplified. Last thing you do is 9 minus 4, which is 5. So that's a lot of steps. It takes a lot of time, and there's a lot of places to go wrong. So if you're not really good at this, I would suggest guessing and moving on. I'll do one more as an example before we move on. Okay. So 2 will go into 10, so we're using 10. It's already 10, so we move our 3 over. 2 has to get multiplied by 5, so therefore the 1 has to get multiplied by 5. You end up with 5. So 3 can't subtract 5. Don't ever subtract up. I see people do that all the time also. 3 minus 5 is not the same thing as 5 minus 3. Don't just put a 2 down here because 5 minus 3 is 2. It's always the top number subtracting the bottom number. And you're not going to have negatives when you're dealing with these types of fraction problems. So we borrow. Mark out the 8, make it a 7. Our denominator is 10, so our new denominator is 10, which means our numerator is 10, which means you end up with 13. Now I did this on purpose. The only time that there's going to be a 1 that goes in front of the 3 is when your denominator is 10, because you're basically adding 10 to that. 10 plus 3 is going to be 13. That's the only time that a 1 shows up in front of the 3. Every other time, it's going to be basically the denominator added to the numerator to get 45. So now we can subtract 13 minus 5. That gives us 8. Bring down our 10. Now, before I move on, you'll notice that these are both even, so they're both divisible by 2, which is 4/5. The last thing I do is 7 minus 2, which is 5. Bring my fraction over. There's my final answer. I'm going to do one problem on each of these pages. Now, if your numerator is already the same, you can just leave these horizontal. So 9 is a denominator, so 9 stays. 1 plus 6 is 7. Make sure that's simplified. It is, so you're done. All the answers to these are on the back. So when it's like this, don't try to do this horizontally. Just go ahead and rewrite it vertically. 1/4 plus 4/5. 4 and 5 will go into 20 times 5 times 4, 16. So we actually end up with 21 over 20. So we have an improper. So 21 divided by 20 is 1. And you got 1 left over, so that's your new numerator. You'll probably have to do these on a separate sheet of paper because you don't really have room over here to work all these. You see, I took up 2 spots to do all that. So your final answer is 1 1/20. Rewrite these top over bottom. 1/2 plus 6 2/4. It's funny, sometimes they give you fractions that are already not simplified, but it's okay. So this is a good example. You'll see why. Oh, 2 will go into 4, so I'm using 4. Bring my 2 over, multiply times 2. So 2/4 and 2/4 is 4/4. That's still an improper fraction. If you divide 4 by 4, you get 1. You're not always going to get a remainder, especially in the case of having one number over itself. So you just take that 1 and add it back to this 1 and this 6, and you end up with 8, no fraction. You're not always going to have a whole number and a fraction. Sometimes they'll even out If you had 8 over 4, it would have been 2. But that's not going to happen in adding. It's only going to happen in multiplying. So your final answer for number 1 is just 8. Now, let me make sure this is going to be borrowing. Let's skip one. That's not a good example. This one's going to be borrowing. Some of these you have to borrow and some you don't. I gave you 2 borrowing examples. You're not always going to have to borrow. Sometimes you'll have enough on top to subtract. 3 and 5 go into 15 times 5 gives you 10 times 3 gives you 3. And I know that I'm going through these fast. It's because my video is running long. I don't expect you to be able to do these as fast as me, especially if you're just learning them. So take your time. You can always rewind the video and start it over and watch again. 3 minus 10 can't happen. Come over to the 8. Borrow 1. Add 15 over 15. 3 plus 15 is 18. Over 15. 18 minus 10 is 8. And 8 and 15 don't share anything except 1. 7 minus 3 is 4. And you're done. All the answers to those are on the back so you can check yourself. And that is the end of the video for adding and subtracting.